In these last three examples, there's an extra step that we need to do because each of these binomials has a greatest common factor. And when you're factoring, that should be the first thing you check for. In 36, the greatest common factor between these two terms is 2. If we factor out a 2, that leaves h squared minus 1. Well, I know that is h squared minus 1 squared because 1 is a perfect square. And now that follows the difference of squares pattern, h plus 1, h minus 1. In number 37, this binomial has a greatest common factor of 3. If we factor out a 3, that leaves 9w squared minus 4. I recognize that these two terms are a difference of squares. 3w squared minus 2 squared. Once I recognize this pattern, I know it factors to be 3w plus 2, 3w minus 2. And last but not least, we have 80g squared minus 45. And we know that the GCF between these two terms is 5. So if we factor out of 5, that leaves 16g squared minus 9. I recognize that that binomial is a difference of squares. It is 4g squared minus 3 squared. So that is going to factor to be 4g plus 3, 4g minus 3. And notice in all three of these problems, the greatest common factor does not go away. It just stays in front of your two binomial factors.